Hello students, I am Sagar Sharma and today I am going to start a new topic, that is your strength of material. I am going to deal strength of material for your GATE Aerospace batch and will try to uh, provide you the best possible classes so that you can understand the subject from the basic, from the very fundamental, and you can excel in the course as we will proceed. We will try to make it very crisp for you so that things will be very much easy. And also with that, I will try to add some very good practice problems with the real life problems so that strength of material can be helpful for you. So this is a session where we are going to where we are going to study the basic terms that is known as load. So in the very first lecture, I will try to deal with topics like load. What do you mean by a load in your strength of material? So let us try to define what load is, or how we can actually write out what is a load. So it is an external force, it is an external force or movement. It is an external force or movement experienced by a body. So what do a load means? A load basically means any externally applied force, any externally applied force or a movement. It can be a bending movement or it can be a twisting movement applied to the body. So suppose that we have a particular body. Let us take an example of a body. Suppose this is a particular body that we have. Okay. So on this body, if we apply any external force on this body, if we apply any external force, this external force will be termed as load. This external force will be termed as load. Now not only this particular load, this particular force will be termed as load, we can also define it as the movement. Maybe it is the bending movement or the twisting movement applied on the body. This will also be categorized as your load. Hoping so you are able to understand this concept. Okay, so any external force, any external movement, any external force applied to the body, that will be termed as your load. Now let us try to classify the load. Okay, so these loads are further classified. These loads are further classified as, there are certain classifications that we have to understand. Like the very first type of classification that we have is based on direction of load. So what is the direction of load? How the load is applied on the body. Okay. We will try to define it in a very detailed manner. Okay. So first we have to understand what does the direction of load means, how the load is applied on the body. Okay. So there are various methods. Like if we try to understand a particular, let us try to take a particular body. So this is a body that is in front of you. We have a particular body in front of us. Okay. So along this body, from the center, this particular axis will be known as your longitudinal axis. This axis is known as your longitudinal axis, and if a load is applied parallel to this axis, from the center, this load will be termed as your axial load or longitudinal load. So it will be termed as your axial or longitudinal load. Longitudinal load. So this is one of the way to express the direction of load. Or there is one more condition that we can have. If the load is applied, perpendicular to the longitudinal axis, it will be termed as your shear stress or shear load. We are going to consider it as a shear load. So if the load is applied perpendicular to the longitudinal axis, it will be termed as your shear load. If it is applied parallel to the longitudinal axis, it will be termed as axial load or longitudinal load. So let us try to just write it down in the way. Okay, so on the basis of direction, we have two different types of loads. First one is your axial or longitudinal load. Axial or longitudinal load. Now let us define what is an axial load. It is the load being applied parallel to the axis of member. Parallel to the axis of member. So for a particular given member, we will have a particular given member. Let us try to see a particular given member. Okay, so let us take a particular member. This is a particular member, and on this particular member, suppose we have this. Okay, and now we are applying the load. Okay, this will be your longitudinal axis. If the load is applied parallel to this, suppose here the load is applied or the load is applied like this, or the load is applied like this. There are various methods to apply a load. Okay, so let us take these cases. This is case number 1, this is case number 2, and this is case number 3. In all these 3 cases, you will see that the load is applied parallel to the axis of the member. Okay, so here this is the axis of the member. This is known as your axis or longitudinal axis. This is the axis of member, and you can see that here the load is applied actually parallel to the axis of member. So whenever the load is applied parallel to the axis of member, the position does not differ here, like the position can be anywhere. Okay, so it is not required to be exactly on the line of the axis of member. It can be eccentric also, it can be away from it, but if the load is applied parallel to the axis of the member, then that will be classified as your axial or longitudinal load. Are you able to understand this? In all the above cases, like the case number 1, 2 and 3, these all three are axial or longitudinal loads. So we can say that 1, 2 and 3 all are all are axial or longitudinal load. Longitudinal loads. They all are longitudinal loads. ठीक है? Are you able to understand this? Now, if you can see that there are two different types of loads that we have here. The first one, if you try to see this particular code, this load is coming out type load, coming out of the body. This load is actually coming out of the body. Similarly, if you see this load, you can see that this is also coming out of the body type load. It is pointing outwards of the body. The load is pointing outwards of the body. Now, these two particular loads are commonly known as your tensile load. They are known as tensile load, or they are known as tension. Okay, so whenever the load is coming out of the body or the load is pointing out of the body, it will be termed as your tensile load. And if you try to see this particular load, you will see that this is pointing towards the body or it is coming inside the body. This particular type of load is known as your compressive load. Okay, so this is your coming towards the body, load coming towards the body. This load is known as your compressive load. So, there are two types of load we will have. Now, let us try to understand them. Okay, this load is actually eccentric one. This is eccentric one. We will study about it. The third number load here is your eccentric loading. Even the first number load is your eccentric loading. We are not discussing about that right now. We will understand that particular portion later on, but here we are only trying to understand the different types of load that we have. Okay, just basic understanding. We will come to the topics like eccentric loading also. We will come to the topic like eccentric loading. We will come to the topic like eccentric shear loading. There are different types of cases that we can have. Okay, so if we try to understand that, we can say that it may be tensile, it may be tensile or compressive in nature. It may be tensile or compressive in nature. It may be tensile or compressive in nature. Okay, it may be eccentric, it may be eccentric or concentric in nature. It may be eccentric or concentric in nature. There can be various cases possible. Okay, so there are various possible cases, like we can say that the case number 2, ठीक है, figure 2 is your tensile load, is your tensile concentric load. So it is passing to the center. Okay, concentric load. We will understand about that. What do you mean by center? Okay, there are various centers, the body center, the axis center. We will define various type of centers. Okay, and similarly the figure 1 and 3. The figure 1 and 3, the figure 1 and 3, ठीक है, the figure 1 and 3 are eccentric loads. Figure 1 and 3 are eccentric load. Are we able to understand this? Are we able to understand this? Now, the second type of loading, this is your first type of loading. The second type of loading that we have is known as, transverse loading. The first one is your axial load, second one is your transverse load. Now this load will be perpendicular to the axis of member. If the load is applied perpendicular to the axis of member, then it will be termed as your axial load. Okay, it will be termed as your axial load. What I am saying is, by definition, it is the load applied. It is the load applied. It is the load applied, or we can say that it is defined. It is defined as the load applied perpendicular to the axis of member. Perpendicular to the axis of member, it is defined as the load applied perpendicular to the axis of member. Okay, the load applied perpendicular to the axis of member. You can draw it like this also. Okay, that will be your shear load if you try to understand. So let us suppose this is your, and now here these are the two bodies, and here you have your circle. Okay, this is the center, and you can see that on the center at the exact mid you will have your, okay. Now let us suppose that there is one more axis, and the axis is somewhat like this. These two axes are perpendicular to each other. Okay, they are perpendicular axes, these two axes, and now the load is applied like this. The load is applied like this. We are applying a load like this. Okay, suppose a load is applied like this. So the yellow color is not visible properly. Let me change the color. Yes, the load is applied perpendicular to this, or the load is somewhat like applied like this. You can see the load in this direction also, from the center this. So it is perpendicular. Okay, just understand this thing. The load that we are applying here is perpendicular. Okay, the load is perpendicular. Okay, if you try to see this with the help of a cross sectional axis, let us try to view this using a cross sectional axis. Okay, so if we try to view it using a cross sectional axis, okay, and suppose this is your cross section. Okay, so if you try to see it, and if you try to plot it again, if you try to plot the center will be somewhat like this, and here it will be like this. Now you will try to see the force. The load is somewhat like this. Initially this is your red one, this is your red load, and similarly the green load is somewhat like this. Okay, so just try to understand the basic concept that I am trying to help you with. Okay, so you will be able to understand that the axis, this is your actual axis. If you try to feel, this one is the major axis, this one is your this is the axis of the member, this is the axis of the member, this is the axis of the member, and you can see that and you can see that this is the axis of the member, and you can see that these forces are actually perpendicular. These forces are actually perpendicular. These forces are actually perpendicular. They are actually perpendicular to the axis of the member. So actually they are perpendicular to the axis of member. Okay, just remember this thing. These forces are perpendicular to the axis of member. They are perpendicular to the axis of member. Okay, are you able to understand this? Now I am pretty much sure that you understand the basic concept of the transversal load, and also you understand the basic concept of the longitudinal or the axis load. Now let us move to the next part of the loading. The next part of the loading, that is the B type of the loading, is based on extent of loading. It is based on extent of loading. It is based on the extent of loading. Now what is the extent of loading? Here by this particular term extent, we are trying to understand the distribution of the load. Okay, here we are trying to understand the distribution of the load. Now suppose that we have a particular beam like this. Okay, we have a particular beam like this. We have a particular beam like this. We have a particular beam like this. Suppose this beam is, let us assume that this beam is pin jointed here, and there is a roller support here. We will try to understand the different types of support later on in the later stages. And suppose that a particular load is applied on any of the part. Let us suppose that here a load is applied. Here a point load is applied. Okay, a single load. This is known as your concentrated load. It is known as your concentrated load. A load which is solely applied at a fixed point. It is known as your concentrated load. Okay, so if a load is applied at a particular point, then that particular load will be known as your concentrated load. While there is one more different type of load which is known as your distributed load. So suppose that if I apply a particular load like this, if I apply a particular load like this, if I apply a particular load like this, so now you can see that here the same particular load, we are not discussing about the magnitude, but we can say that the same particular load is now distributed on a larger area. So this is your distributed load. This is known as your distributed load. The load which is distributed, along a particular length. Okay, so these are the different types of loading conditions that we have as on the basis of extent of loading. So on the basis of extent of loading, there are different types of loading that we can have. Okay, so let us try to understand this. So if we try to see this, we can say that there are two different types of loading conditions that we can have. The first one is point load. The first one is your point load. Now what is a point load? if we define a point load, we can say that if load axis, if load acts on a comparatively smaller area or at a particular point, what I am saying is that if load acts on a comparatively smaller area or at a particular point, then that load is known as a point load. Okay. So, if the load is applied at a fixed point, at a fixed area, at a fixed region, then it will be known as a point load. Okay. It will be known as a point load. The second type of loading condition that we have is your distributed load. The second type of loading that we have is your distributed load. Okay, so if load is distributed, if the load is distributed over a larger area, if the load is distributed over a larger area or it is distributed over a particular length, comma, then the type of load is known as distributed load. Then the type of load is known as distributed load. Are we able to understand this? So, if the load is actually variable in nature, then it will be termed as your distributed load. Okay. So, this is it in the very first session. Hoping so you are able to understand the condition. The remaining portion of the loads will be discussed in the next lecture, and we will try to understand it in more basic manner. So, this is Sagar Sharma and your mentor for strength of material and vibration part, and hoping so you love the session. Thank you so much.